So I work for IGT, and this project this year. Last year I saw the project that EB was doing on digital twins. That's kind of where I got this idea from. So my name is Robert Corvasi. I'm a product architect. I also work in the innovation side of the house. Ray Leland, who's not here, he's done projects before. He's a director of firmware at IGT. So IGT, some people may know us by GTECH. For years and years we were GTECH. So I forget how many years back now, we bought out IGT, which was a slot machine manufacturer, and for some reason they took their name. So we're one of the world's largest lottery provider. We do, I'm sure you're familiar with scratch tickets and Powerball jackpots and stuff like that. So we do everything from retail locations to now mobile, online. So you can pretty much purchase lottery just about anywhere now. Across the globe, we're over 12,000 people. One of our main headquarters is here in Providence. I work in West Greenwich. That's where we'll be meeting, in West Greenwich. Most of all of engineering is in West Greenwich. We have other hubs in Warsaw and a big one there, and other places throughout the world, really. So we provide gaming solutions, like I was talking about, gaming, lottery, interactive, and social venues. Like I was saying, gaming across various channels. We also have IGT printing, which is down in Florida. That's where they print all the scratch tickets. And we have interactive gaming. So these are the various, we'll call point of sale devices, or now we're calling them TouchPoints. So here, the first one here you see is what you typically see in a retail location. We have various self-service machines. So the focus of the project will really be on the lottery terminals. So we want to make a digital twin of the lottery, whether it's retail or self-service. And there's a lot of different components, especially in our self-service machines, because we have bursters in there for dispensing instant tickets. There's credit card modules, there's bill acceptors, coin acceptors, barcode readers, different types of scanners that we put in there for scanning bet slips, security boards. So there's a lot of things going on in the self-service machines. On the retail terminal side, there's a lot of devices as well. I don't know if you've ever seen play slip readers that we have in there. Obviously touch screens, barcode readers, various signs that we connect, printers. We're also supporting tablets. We won't be doing anything with those or the smart terminals on the end, which are like third-party devices. So this is what our terminal stack looks like. So we're all Linux is what we run on all our terminals. Our application is all written in Java. This architecture is relatively new, probably the last couple of years. So we actually run a web server on our terminals. So all the screens are all written in HTML5. They're all web-based. At some point, we want to kind of push the server out of the machine. One of our restrictions right now is really bandwidth to a lot of retail locations, but that's slowly changing now. So project motivation. So our terminals, typically, when we sell them, they stay deployed for a long time. It used to be like 5-year contracts. Now we're like pushing 15, 20-year contracts. So somewhere along the lines, we're doing refresh on hardware. Obviously, there's a lot of field service that's going on during the life of those contracts. So being able to maintain these machines and keep them up and running is a priority. IGT faces what they call when we do a facility management, which means like Rhode Island, We bring in all the equipment, the central systems, everything, and we just maintain everything. So that's all, IGT pays for all that. It maintains all that. And we have service level agreements with them. So if, say the terminals go down, we start incurring penalties for lost sales. So we have to pay all that. And Rhode Island, I think, is like a couple thousand terminals. Places like UK, it can be like 45,000 terminals. So as soon as those machines down, the dollars start ticking pretty fast. So, so being able to monitor these machines and being able to, know when they need some, we can determine some predictive maintenance that needs to happen on these machines, know when something might be failing, and getting out there being proactive ahead of time is really important to us. We're currently working, actually the next release that we're making a software for the terminals, we're going to have our first set of telemetry that we're going to be collecting from these machines. So that's something we haven't done to date. And in going through, what we can collect on these machines, things, field service are looking for things that we can't monitor right now. Like input voltage to these devices. Are they, is it 130 volts? Is it 90 volts? What are they running on? So things like that, we want to add more sensors to our devices to be able to get a real good representation of a digital twin. Let's see. So let's see. This project will explore the following. We want to, create an accurate copy of a TouchPoint, like I was talking about. Use various monitoring and diagnostics. We want to optimize performance if we can. We want to add more sensory data to it. And, as from a point of, predictive maintenance. So project details, digital twin should be able to do the following. We want to receive TouchPoint telemetry that we're collecting right now, and we want to be able to add more. We want to be able to view the, the status of the touch-pointed device in the digital world to see that twin. We want to be able, like I was saying, add more sensory data. We want to be able to provide this data in near real time. So now we have a mechanism in place to do that based on our limitations as far as communications are concerned. Let's see, I talked about expanding sensor data. So we also want, that's kind of on the hardware side of it. On the flip side of it, as far as, the software platforms that are used for digital twins, that's certainly a brand new area for us. So I'm looking forward to, having you guys research what's available out there, what can be used, look at the different vendors, what their capabilities are, what they can provide. So that's going to be part of the project as well. So anticipated best outcome. So we'd like, we want to instrument one of our TouchPoint devices. We want to collect all this data that we're collecting now and add more data, more sensors to it. Determine what, what would be ideal to add as far as more data. And we want a realistic view of the digital twin on the back end. So back on the server side, we want to see what that looks like. And, we want to be able to display, fault conditions or warning conditions, things that might be happening in the device. So electrical tasks would be, gain familiarity with, IGT systems, research, determine, various hardware that we're going to need to do this IoT. Design and implement underlying circuitry. We're going to need to interface that all to the back-end system. Obviously, cost is very important to any of these devices, so that needs to be taken into consideration. So firmware tasks, again, same kind of bullets on the top here. the underlying, I guess the important one is probably the bullet on the bottom there. So any of the new data that we're going to collect, we're going to have to write some software in order to collect that data. Like I said, we have a mechanism for transmitting that data up now, but that underlying drivers and interfaces we're going to need to the new sensors would have to be written. Software, that's going to be more on the back end, the service side, taking in all this data, rendering with using it for the digital twin. So in the end, we want a functional prototype is what we're looking for. Like I said, it'll either be a self-service machine if we end up wanting to tackle that, or one of the retailer machines. And on the back end, we want to be able to see that digital twin and its, all its various sensors, all the various data that we're collecting. So broader implications. So IGT, we'll have, like I said, when we deploy these machines out in the field, they're out there for many, many, many years. So, the health of the machine, keeping it up and running is very important. We want to be able to reduce field service visits, or when we have technicians out there maybe doing or installing some new equipment, if there's some preventive maintenance that we can do on it while we have the technicians out there, we want to be able to schedule that, but we need to know it, that we need to do it. And that's pretty much the project.